Hey kiddos, hope everyone's doing well. In this video we're going to talk about how to find sides, and I call that solving, and in this case right triangles. So we're going to think about how to solve right triangles that are not special. Isn't that special? So what I mean by are not special, they're not either a 30, 60, 90 or 45, 45, 90 triangle. Okay? So we talk about, if we have one side, if we know one side, and we know it's a right triangle, and we know it's a special right triangle, we can get the other two sides, right? So what if it's not? So what if we know one side, what if we know it's a right triangle, and what if it's not a 30, 60, 90, or a 45, 45, 90? Question is, how can we get the other side, missing side? Well, there's an answer for that, obviously, and it's mathematical, and it has to do with three pretty special trigonometric functions, and we're going to get into them a little bit now at a very superficial level. So for now, I just want you to be able to understand how we can use these to solve right triangles. So here's where we start. We start with a right triangle. It has to be right triangle, okay? It's got to be a right triangle. And from that right triangle, we kind of declare a reference angle. And I'm going to call that x. So x is our reference angle. It's the angle from which we're looking out into the triangle. And based on this reference angle, we have three sides, right? And it's relative to the reference angle that we define, we name each of these three sides, right? So from this reference angle to the opposite side, I'm going to call that O. O for opposite. And it's opposite the reference angle, which we call x, right? That's why we call it O for opposite, right? Now, regardless of where my reference triangle is, the side across from 90 is going to be the hypotenuse, right? So we're going to call that H, right? So that's H, yeah. So the side across from 90 is always called H, right? And the side that's not the opposite side, nor is it the hypotenuse, is called the adjacent side. And A is the adjacent side. Okay, and H is for hypotenuse. Right, so we have three sides, and what happens is, depending on where our reference angle is, our opposite and our adjacent could potentially switch, right? But the hypotenuse is always the biggest side across from 90, right? No matter which non-right reference angle I use. And we always use one of the two non-right angles as our reference angle. Okay, so based on that setup, we're going to define three new trigonometric functions. Okay, and we call these functions a sine, and I pronounce that sine. It's, if I were to write it out, it's really S-I-N-E. But the sine of that angle x is equal to the ratio of the opposite over the hypotenuse side. That's called the sine ratio for any right triangle with reference angle x and opposite side O, hypotenuse H. Another function that we define, a trigonometric function, is called the cosine. And we say the cosine, and it's spelled cosine, but we abbreviate it COS for cosine. The cosine of that reference angle x is equal to the ratio of the adjacent side over the hypotenuse. The third relationship is called the tangent. And the tangent, spelled out tangent, abbreviated tan, the tangent of that angle x, the reference angle, is equal to the ratio of the opposite over the adjacent side. Okay? And these are three very new to you functions. They're called trigonometric functions. Okay? There's a way to remember this, and we call it SohCahToa. And all SohCahToa helps us remember is that the sine of that angle is equal to O over H. So, sine S, O over H. The cosine of that reference angle for that right triangle is equal to the A over H, the adjacent over hypotenuse. Cosine, A over H. And then the tangent of that reference angle is equal to the opposite over adjacent. Tangent T, opposite over adjacent, TOA. Okay? So let's see how we could have used this in our last little experiment, right? And so we had this height that we were looking for. I'll call that x, right? And we're trying to find the height of the chapel. And we kind of walked out here, and we had to use a 30, 60, 90 angle. Some of us forgot to add that little height of the observer, right? Whether it be 5 feet or 6 feet or whatever the case may be. But we had to make this angle 30 or 60 or 45, so we can use those special right triangles. But what if it was probably easier if we just stood at a point and measure the angle and then measure the distance we were from the chapel, right? So probably easier to do that. So what if we got, let's say, at 54 degrees, we were, I don't know, let's say 100 feet from the chapel, right? How can we solve for x? Well, using this as my reference angle, the 54-degree angle, the side I'm looking for is called the opposite side. Okay? So I know the angle, check. I assume it's a right triangle, which we have to, check. And I know one of the sides. So I'm going to declare first the sides relative to this 54-degree reference angle that I am looking for, and I know. So 54 degrees is the across from x, which is what I'm looking for. I'm going to call that O for opposite, right? The hypotenuse is up here across from 90, and the side that's underneath this reference angle is called the adjacent, right? So I first kind of declare each of the names of the sides. Adjacent, opposite, hypotenuse, right? I don't really need or care about the hypotenuse for this problem. What I have is I have the adjacent side. So I have the adjacent, and I want to know the opposite side, right? So I'm going to use that relationship that has the O and the A in it, right? I'm looking for the opposite, O, and I have A. So I'm going to use a tangent relationship, right? So here's how I set up. Again, I use the tangent because I have the adjacent 100 side relative to this reference angle, and I'm looking for the side opposite. I have A, I know O, right? Actually, I want to know O, rather. I don't have that. I want to know the opposite side, so I use the tangent, O over A. So I'm going to set up this handy-dandy equation, right? Here's how I would solve that. So I'm going to create this nice little equation that would say the tangent of that 54-degree angle is equal to the ratio of x, which is what I'm looking for, over the adjacent side, right? Remember, tangent of x equals opposite over adjacent, right? In this case, my opposite side is what I'm looking for. The adjacent side is 100, right? And I use tangent of this reference angle, 54 degrees, right? And so now I'm going to turn to my calculator to help me solve for that, right? Now, algebraically, in order to solve for x, I'm just going to multiply both sides by 100. Whoop. Right? So x ends up being 100 times the tangent of 54 degrees. Right now I'm going to turn to my calculator, turn it on. Come on, calc. There we go. And the first thing I want you to do is make sure you're in the right mode. So I'm going to press this mode, right, which is right here, right next to the second yellow button. And I want you to make sure you're in degree mode, right? So if you're not in degree mode, use the arrows to go down a degree, press enter, all right? There are two ways to measure angles. One is degree, one is radians, okay? We're in 54 degrees, we want to be in degrees. Once that's in degree mode, press enter, highlight it, and then we can quit that menu. Okay? Now look at what x is. It's 100 times tangent of 54, right? So all I'm going to do in my calculator is press 100 times, you don't even need the times, tangent. Now tangent is its own button right here. You see sine, cosine, tangent of 54 degrees. Okay, I press enter. There's my opposite side. Okay. So what I just found is this side here, the height of the chapel, well, really 5 feet less than the height of the chapel, approximately. So this side would be about 137.638 feet, okay, based on this problem. All right, now I want you to consider this problem. Try this on your own. Let's say I have a right triangle. this angle is not 30, it's not 60, it's not 45, but let's say it's, I don't know, we'll call that 49 degrees. And let's say I know the hypotenuse is 20 feet, and I want you to find this side here, right? I'll give you a hint. This is my reference angle. What's the name of this side? Very good, the opposite side. This is my reference angle, 49. What's this side called that I'm looking for? Very good, the adjacent side. And it doesn't matter where my reference angle, this side across from 90 will always be the hypotenuse. Very good. Okay. So for this problem, I don't really care about this side. So I know it's a right triangle. I have my angle. I know the hypotenuse. I want the adjacent. So which of the three relationships will I use? Well, the one that has an A and an H in it, right? The cosine, right? Because I have the A and the H, so I use the cosine relationship. So therefore, I am going to use the cosine of that angle is equal to the ratio of the adjacent over hypotenuse. That's the ka part. Part of SohCahToa, right? So here's all I have to do now is plug and chug. So the cosine of the angle, which is 49, very good, is equal to, it's my reference angle, the ratio of A, which is what I'm looking for, and H, which is 20. Great. Now to solve for A, what do I do to both sides? Correct. Multiply by 20. Right. So that side A that I'm looking for, the side adjacent, underneath 49 degree reference angle, is equal to 20 times cosine of 49 degrees. I don't know what that is. What I can do though is I can use my calculator. 20 times cosine 49. You guys doing this at home with me? Excellent. Press equal. There we go. There's my adjacent side. 13.121. It's approximately. Okay. So these three functions, sine, cosine, and tangent, just give us a different way of solving triangles that are right, but they're not special. That reference angle is not 30, 60, or 45 degrees. Okay? Called SohCahToa. Sine, cosine, tangent. Hope you enjoyed this video. Come in ready to go tomorrow.